Hello students, welcome once again back to the Learning Management System initiative of the Department of Collegiate and Technical Education. So you all know that I've been teaching the course Particulate Technology, a third semester chemical engineering course in the Diploma in Chemical Engineering program. So you all know that at this position, we have completed already the first three units of the syllabus. So today is the first session of the fourth unit titled Filtration. Let us now see what we are going to learn in this session. So in the third unit, when we discussed in the beginning session about the different techniques of separation of solids from fluids, so we understood that filtration is one of the technique used in industries to separate the solids from suspension in a liquid. So that means we have continued the fluid solid separation techniques that we started in the third unit into the fourth unit also. So this is one widely used method in industries to separate the solids from liquids. So since this is the beginning section, so let me just take you back to the course objective. The objective of the particulate technology course is to make the student understand the principles and analyze, differentiate and explain the various equipments in particulate technology. So this is the course outcome a student will attain after studying this fourth unit filtration. So after he has finished studying the fourth unit, he or she will be able to classify the filtration equipments, understand and apply the principle of various types of filters used in industries. So these are the contents that we are supposed to learn in present session. So first we'll know what is meant by filtration, and later on we will understand the different types of filtration. Then one particular type of filtration, that is cake filtration, its principles are taken up later. And one more topic we are supposed to discuss in today's session, that is a constant pressure and constant rate filtration. So where we will understand what is meant by constant pressure filtration and what is meant by constant rate filtration and how the two are related. So let us first define what is meant by filtration. So we already know the definition. So in the first class of the third unit, I told you about filtration. So filtration is that unit operation in which the suspended solids from a liquid are separated by using a porous medium called filter medium, which retains the solids and allows the liquid to pass through. So that is how basically a filtration operation separates the solids from liquids. So it is a separation of solids from a suspension and a liquid with the help of a porous medium or a screen which retains the solids and allows the liquid to pass through it. So this is termed as filtration. So, so this is a simple diagram explaining you how you can achieve the separation of solids from a liquid by using filtration operation. See, this is the screen or the porous medium that we are using to achieve the separation of solids from liquids. So this feed is nothing but the suspension or the slurry, so which will be admitted to the upper side of the filter medium, and the solid particles being larger in size compared to the pore size of the filter medium cannot pass through the filter medium. So either it gets attached or stick to the holes, or it entirely lies on the surface of the filter medium. Whereas the liquid particles, the small dots what you can see, so that represent the liquid particles. So they being small in size, that they can pass through the pores of the filter medium. So that liquid that is coming out of the filter medium is called the filtrate, and the solids which deposit on the filter medium is called as cake. So that is how we can separate the solids from liquids using filtration. So in a filtration operation, the suspension that you are going to handle may contain a small proportion of solid, or the proportion of solids may be quite large. And After filtration, either the solid that is separated may be the product, or the liquid that is separated in the form of filtrate may be the product, or in some cases both may be the useful products, or in some other cases neither of them are the products. For example, in the effluent treatment, that is in the wastewater treatment process, the waste liquid will contain some suspended solid. So here the entire waste that is going out of industry is not required, or it's the it's not the product. So the purpose of separating solid from that wastewater is to separate the solid and give a separate treatment, and the liquid separated also given a certain treatment, and after that both are disposed. Anyway, they are wastes here. So even though they are waste, the separation is to be carried out. So that is how the product in a filtration operation varies from different cases. So the driving force that is required for filtration are either the gravitational force, vacuum force, pressure force, or centrifugal force. So in case where the gravitational force is the driving force, so we have a gravity filters, and wherever we have the vacuum as a driving force, you have a vacuum filters. Then where pressure force is used as a driving force, it's called pressure filter. So centrifugal force is used in actually the centrifuges, that is centrifugal filters, which we have already finished discussing in the third unit. So let us now continue the filtration. So let us now understand what are the different types of filtration. Okay, depending upon the nature of separation of solids from liquids, there are two types of filtration. One is called cake filtration, other one is called deep bed filtration. So cake filtration means it is that filtration operation in which the amount of solids that is to be separated is usually large compared to deep bed filtration. So in this particular operation, the filter medium will be in the form of a screen, and the solids will not pass through the filter medium. It almost gets deposited on the filter medium in the form of cake. So hence it is called as cake filtration. So whereas in deep bed filtration, the solids that are to be separated are usually small in quantity. Then here the filter medium will be in the form of a bed of certain thickness. So the solid particles actually penetrate through that filter medium, but it gets stuck inside the filter medium, but it will not come out from the other side along with the filtrate. So cake filtration is usually carried out to separate large quantity of particles or the solid suspension in a liquid. So bed filtration is usually carried out to produce sparkling clear liquids. So let us now understand cake filtration. The proportion of solids in the suspension is quite large, as I already told you. Most of the solid particles are collected in the cake, which can later be detached from the filter medium. So the solids go on depositing on the filter medium during the filtration operation. So that deposition is called as a cake. So when that cake gets collected up to certain level, you need to take it out from the filter medium. Otherwise, you cannot continue the cake filtration. So the solids need to be detached from the filter medium, since the quantity of solids that are to be separated is large in this type of filtration. And the filters which use this kind of filtration are called cake filters. So cake filters are the one which separate large amounts of solids from the in the form of cake of crystals from the liquids. So these are the one which usually find application in chemical process industries. So the filters whichever employ filter cloths or cellulose membrane filter medium are the one which are called as cake filters. Okay, so this diagram is showing you the difference between the cake bed filtration and the deep bed filtration. So in case of cake filtration as shown in figure A, so this is a filter medium which is not very thick in size. So and the particles that are to be separated will deposit it over the surface of the filter medium. So even though some few solids might enter the pores, so they'll just serve to block the force, but it will not come out from the other side of the filter medium. So they get deposited on the filter medium when the slurry enters the filter medium, and only the liquid can pass through and come out from the opposite side as filtrate. So this is cake filtration, so which usually involves the formation of cake. So as there is a large quantity of solids that are separated from liquids. So this is how deep bed filtration consists of a filter medium. So here the filter medium is in the form of a deep bed. So this bed has channels like this, and the particles that are to be separated actually uh, pass through these channels, but somehow they get attached inside the channel and won't come out from the other side. Okay, so the particles will be able to penetrate the pores but cannot come out of the deep bed, and only the liquid comes out from the other side. So that is what is known as deep bed filtration. There is one more filtration type called cross flow filtration. Here the suspension or the slurry will flow in a direction parallel to the surface of the filter medium. So this is also one type of filtration. So but it is not that widely found compared to the first two types of filtration. So that is about the different types of filtration. Okay, so understand deep bed filtration now. It is the one filtration in which the proportion of solids is very small and the particles of solids being smaller than the pores of the filter medium will penetrate a considerable depth and ultimately get trapped inside the filter medium, and usually you will find no layer of solid on the surface of the filter medium. So that is the nature of deep bed filtration. So whichever filter that employ this kind of filtration operation are called deep bed filters or clarifying filters. So these are used to remove small amounts of solids to produce sparkling clear liquids. So clarifying filters find limited use in the industries. In fact, they are found useful in the treatment of water to remove a small quantity of suspended solid impurities, so which are finely divided suspended solids by filtration operation. So sand filter is the one which act as a deep bed filter. So this is an example for deep bed filtration. Let us now understand first the principle involved in a cake filtration. That is because cake filtration is the one which has found wider use in industrial filters. So in cake filtration, the feed to be handled, which is a two-phase mixture containing solid and liquid, is called slurry, and the bed of deposited solids on the porous membrane, that is filter medium, is called cake, and the clear liquid that is leaving the filter medium is called filtrate. So this explains the principle of a cake filtration. As shown in figure, the slurry will be fed to a chamber in which filter medium is fixed with a support at the bottom. So over this support, there is a filter medium which is porous in nature. Then the solids will be retained on the filter medium. So as soon as the slurry enters here, the solids start getting deposited on the surface of the filter medium, and the filtrate, that is a liquid, passes through the pores of the filter medium, comes out from the bottom outlet as a filtrate. So the solids retained on the filter medium while the liquid flows out through the openings. So during the initial period of flow, the solids are trapped within the pores of the filter medium, forming a true filter medium. So during the initial stage, what happens is some of the solids uh, will block the pores of the filter medium. So they get trapped inside the pores of the filter medium, and that actually forms the filter medium. So from then onwards, that is the layer which acts as a filter medium, because those are solid particles cannot be again removed. So only the solids which are deposited over the surface of the filter medium will be taken out as a filter cake. So during the initial period of flow, solid particles are trapped within the pores of the filter medium, and that forms the true filter medium. So now the liquid will pass through the bed of solids and through the filter medium. So the passing of the liquid will occur first through the bed of solids, that is deposited as a cake, and then through the pores of the filter medium. So if it has to come out in the form of a clear liquid called filtrate. So for a given pressure difference, means the difference in pressure between the upper side and the lower side of the filter medium. So this side is called upstream side of the filter medium, and this is the downstream side of the filter medium. The difference in pressure between these two sides is called pressure difference. And for a given pressure difference across the filter medium, the rate of filtration is high during the initial stages of the filtration, and it actually decreases as the cake thickness increases, because more amount of cake means more resistance to the flow of filtrate, because the filtrate has to pass through the channels in the cake and then through the pores in the filter medium. So as the cake thickness builds up, the resistance to flow of filtrate increases. So whatever rate that you obtain at the beginning is the maximum, and that rate of filtration goes on decreasing as the filtration operation proceeds. So that is how the cake filtration takes place. So you cannot let the cake deposit for a quite long time. So once the cake is deposited up to certain height, then you cannot continue the filtration, because the further filtration cannot take place at the desired rate. So you have to remove the cake by detaching the cake from the filter medium, and then again can be used as a filter medium for next cycle of operation. Okay, so that completes the principles of different types of filtration. So let us now understand what is constant pressure filtration and constant rate filtration. So depending upon the pressure drop across the filter medium, so we can classify the filtration operation as a constant pressure filtration and a constant rate filtration. So what is constant pressure filtration? So if the pressure drop over the filter medium throughout a filtration run is held constant, then the rate of filtration will be maximum at the start, and it decreases continuously towards the end of the run, finally becoming minimum at certain cake thickness. So that kind of filtration is called constant pressure filtration. So during which the rate of filtration varies from maximum at the beginning towards a minimum at the end of the cycle. So the pressure drop will be applied in such a way that maximum rate is achieved at the beginning. So if filtration is carried out in this manner, it's called constant pressure filtration. So if the outlet pressure is constant, the constant pressure filtration is carried out by applying certain inlet pressure and maintaining that pressure throughout the run of the filtration operation. So that is how we can carry out constant pressure filtration. What is constant rate filtration? So here the pressure drop across the filter medium is varied such that a constant rate of filtration is maintained right from the start of the filtration up to the end of filtration cycle. So if the filtration is carried out in this manner, then it is called as constant rate filtration. So we will start with a minimum pressure drop at the beginning, and that pressure drop is continuously increased in order to overcome the resistance offered by the filter medium, so that a constant rate of filtration is maintained throughout the run of the cycle. So that method of filtration is called constant rate filtration. So constant rate can be maintained, as I said earlier, by starting at a low inlet pressure and continuously increase the pressure to overcome the resistance of the cake until a maximum pressure is reached towards the end of the cycle. So that is what is known as constant rate filtration. So which one is advantageous and how we can actually carry out the given filtration operation, whether with a constant pressure filtration or a constant rate filtration. So that we need to understand now. The problem with the constant pressure filtration is that initially we apply high initial pressure, which results in a low rate of filtration as the first particles filtered will be compacted into a tight mass that largely fills the pores of the cloth. So application of high initial pressure causes the particles which are filtered in the beginning stages to tightly press against the pores of the filter cloth, thereby blocking the filter cloth pores. So that results in a low rate of filtration. So that is a problem with the constant pressure filtration. So then what is the problem with the constant rate filtration? So in constant rate filtration, the maximum pressure will be reached only towards the end of the run. So the whole cycle of the filtration is operated at less than maximum capacity. So that is the constant rate filtration. So in order to overcome these two disadvantages with the constant pressure filtration and constant rate filtration, so first constant rate filtration is carried out up to a certain time by increasing the pressure, and once the maximum pressure drop is reached, we can carry out with a constant pressure filtration for a remaining period of the filtration. So that is the practical solution that have been thought out to overcome the difficulties faced with the constant pressure filtration and constant rate filtration. So you cannot carry out either with only constant pressure filtration or with the constant rate filtration because both of these methods have their own disadvantages. So what we can do is we can carry out the constant rate filtration until a certain maximum pressure is reached, and after that maximum pressure drop is reached, the pressure drop is maintained constant because you cannot increase any more pressure drop, so that the rate of filtration goes on decreasing, finally becoming a minimum towards the end of the filtration run. So that is how we can carry out the given filtration operation with constant pressure and constant rate filtration. Okay, so with that, let me end today's class. So in today's class, we understood what is meant by filtration. So what are the two types of filtration? That is cake filtration and deep bed filtration or clarifying filtration. So what are the principles of cake filtration? How it is carried out? What is the nature of the equipment in which the cake filtration is carried out? So also we discussed what is constant pressure filtration and constant rate filtration. So with that, let me take leave and let us again meet in the next session to discuss the different types of filters. So let us go through a self-assessment test by answering a few multiple choice questions. The traces of solids are removed from liquid in a classifier, clarifier, leaf filter, rotary drum filter. Okay, so the solution has already come up on the screen. See, traces of solids means only a small quantity of solids are actually removed in a deep bed filter. So this we discussed when we took up the two types of filtration. Okay, so the deep bed filter is also called as clarifier because it produces sparklingly clear liquids. So clarifier is the right answer for this question. The inlet pressure in a constant rate filtration increases continuously, decreases continuously, remains constant, none of the mentioned above. So as the name itself says, it is a constant rate filtration. So if the rate has to be maintained constant, then the pressure has to be varied. So this is carried out by applying certain minimum pressure and continuously increasing the pressure to overcome the cake resistance so that the rate remains constant throughout the run. So in the inlet pressure in a constant rate filtration increases continuously. So option A is the correct answer for second question. So this is your third question coming up. Filtration rate does not depend upon the pressure drop and area of the filtering surface, resistance of the cake and the filter medium, properties of cake and the filtrate, and none of the mentioned. So what do you think is the right option for this question? So think over and try to answer yourself. So is it the pressure drop on which the rate of filtration does not depend upon? Or is it the area of the filtering surface? Or is it the resistance of the cake and the filter medium? So on which the rate of filtration does not depend. So in fact, the rate depends upon all these characteristics. So it depends upon the pressure drop as well as the resistance of the cake and that of the filter medium, and the properties of the cake and the filtrate also affect the rate of filtration. So option D is the right option for this question. Next question. Filtration operation carried out by continuous decrease in the inlet pressure of the slurry is called as dash filtration. Is it constant rate filtration, varying filtration pressure filtration, varying rate filtration? Is it the constant pressure filtration? So if the inlet pressure is continuously increased, then we can maintain the rate of filtration at a constant value. So constant rate filtration is the right answer for the fourth MCQ. So with that, let me end the session. Thank you for joining me. We shall again meet in the next session to discuss more about filtration. Till then, see you.